Welcome, everyone. Thank you for joining us for today's webinar. My name is Tobiloba Adejimo, and I'm the program manager at Amway. I am sure we are very excited about today's presentation. I see a number of people on Zoom already and on YouTube. Good afternoon, Ayotunde. Now, today's session is about setting up Kubernetes. Charles, the co-founder of Maven Code, aims to unblock and especially help with setting up and deploying of containers to clusters, thereby abstracting machines, storage, and networks away from their physical implementations. Now, bearing in mind our housekeeping rules, if you have any questions or propositions, please wait till the end of the session. You can ask your question on Slido using the event code 66678. The next voice you'll be hearing will be Charles's voice, and I urge you to get your pens ready. Thank you very much, Charles, for coming today. Now, over to you.
Oh, yeah, thank you. Yeah, thanks everyone for joining us today. And so far, we've been impressed by the feedback we're getting and all the things you're doing. So I think today is going to be more of an open question and answer session. We're going to go through like setting up of Kubernetes. I know a lot of you guys have been working on that, basically setting up Kubernetes clusters to run Kubeflow and all those good stuff. So I will want to start hearing back from you, your major challenges, the problems you encountered. And I think I have an implementation that I might be able to just run through to just show you on the high level how to set up Kubernetes and get your GKE cluster going. If you're on Google, if you're on Amazon, they have EKS, and on Azure, they have AKS. And some people run it on-prem as well. So they do the Kubernetes setup on-prem and things like that. So how do we get going? Do we want to go through the presentation or do we want to just get onto the question and answer session just to get some feedback from you guys and before we go into the deep dive session? Can everybody hear me? Is everything going on okay?
Yes, hi Charles. Yes, we can hear you. So does anyone have any feedback? You can signify by raise of hand. Yeah. So we unmute you. You can give some feedback before we then go directly into the session. Anybody by show of hands? If you have any question and you're on YouTube, you can drop your question in the chat and a member of the team is going to pick it up. If you're on YouTube and you have a question, just drop it in the chat. A member of the team is going to pick it up. But if you're connected directly on Zoom, here in Zoom, you can signify by raise of hand if you'd like to say something at this point. I think everyone is waiting to hear. I'm sure they've saved questions. There are a couple of questions have been dropped already, but we'll save that till the end. Okay. If there are no questions, perhaps we can just take a deep dive.
Okay, cool. So I'll just go through some of the presentations of some of the things we've done recently on Kubeflow, setting up Kubeflow clusters on Kubernetes. It's going to be high level, so I'm going to expect you guys to trigger a lot of questions around this, and we can take it up from there. So I'm going to just share my screen real quick. Share screen. Can you see it?
Yes, we do.
Okay, then I'm going to go into the present mode and let me know if you can see it. Okay, so today we're going to talk about a lot of things that we're tending towards. And the whole goal of these cohorts around data science, data engineering, and data visual storytelling is to build models that actually go into production. A lot of people spend several thousands of millions of dollars building models, but they never see the light of the day. But companies that successfully build their models and get them into production, those are the companies like Facebook, Uber, LinkedIn, Google. They build their models and they get it all the way to production. And that's when you have things like an inference. That's what you see on your Android phones, where you can have your pictures automatically tagged, facial recognitions, and a lot of all those cool things around it. So the whole idea of this process is for us to be able to understand how we can take a model that we build as data scientists, hand it over to machine learning engineers or data engineers that can take that model and get it all the way into production. And we can now have the visual storytellers talk about the process of pipeline and the whole engineering of what went into the process. So that's basically what we're doing at Maven Code, and we're looking for people to join our teams to be able to help us with this kind of projects. So one of the things that we're taking a heavy bet on is cloud native model training and deployment. So what do I mean by cloud native? They're like applications that you can build and deploy in the cloud, and they can run on-prem as well. But the whole idea is like it's cloud provider agnostic. So you can decide to run it on Google, you can decide to go to Azure, or you can go to Amazon, or you can run it on-prem. The whole idea is like all these things are not tied to a particular vendor and you're not locked in. So for us to achieve that, we've heavily embraced Kubernetes as our underlying infrastructure. So with Kubernetes, you basically have an underlying framework that can allow you to deploy all these applications, mainly as pods or containerized applications. And it's kind of like the way your phone works, where you have a lot of apps and things like that. So your applications are like tiny pods in the scope of things on the Kubernetes ecosystem. And basically they allow you to deploy all these things in the Kubernetes. So we're now taking that approach a little bit more further, and we're applying it to machine learning so that we can basically build our models or train our models on Kubernetes and deploy the models into production. And the whole idea is like, as most of you will know, building models is a very intensive process.
You needed to leave you just now when he was asking for questions. You need to follow through so you know when you interject on it.
Hello? Yeah. So I think there's an audio. So let me know if you have any questions. We'll treat it in like a few minutes. So back to what I was saying, most of you guys have been training models in the last few days, and you're just getting started, but you can see how intensive it is. You need to worry about your data. You need to worry about your code, your algorithm that you're building, and you need to tie all these things together. And just imagine you need to do it every day. Your data set changes so that you don't introduce any bias into the model training process. You need to have a process that can help you scale things out, do it in parallel, and run a lot more faster. And that's where Kubernetes come into play. And that's where MLOps come into play and tying all these things together. So we do a lot of consulting work around these in Maven Code. And like I said earlier, we're looking for smart people to join us and help us move things a little bit more further. So I'm going to be talking about cloud native stack that we use and we deploy for our customers. Most of the time, we try to get them on Kubernetes, not most of the time. So once they're on Kubernetes, then we can install Kubeflow, then we can build all these pipeline components, deploy them, and be able to access them and do things on them. So this is a high level of architecture of what we do. So imagine you're like in a team. You have a lot of data scientists on your team working with you. And you're trying to like build pipelines. Everything needs to be coordinated. You need to do some stuff. Someone else needs to do some other stuff. So in this case, you have a data scientist on a typical team. As your team grows and as you become a part of a big team, you have a lot of data scientists, and you want to be able to coordinate things. You want to, at the end, at the same time, you want to be able to save cost. I don't want you to start up a GPU server and just run your code on it for days and basically make it run the cost up for the organization. So I want to be able to run things and make it scalable and make it a shared resource. So if you're not using a GPU server, you can have someone else take over it and use it. So that's the beauty of Kubernetes, where you have this shared environment. Underline it if you're in the cloud. There's something called auto-scalable nodes. Some of you guys have tried your examples on Google Cloud. You probably saw it, where you have these nodes that can scale on demand. So as more resources added, you can scale it. It's very elastic. And once the utilization goes down below a certain threshold, you can scale it down again. So first, you can have CPU node pool and GPU node pool, and all these resources are managed by Google Cloud, and that's part of the JKE ecosystem. There's the same thing on Amazon with Amazon Fargate and the control plane. You can create exactly the same infrastructure, and we've done it a few times. And on Azure, they have equivalent of this as well. So once we've done that, once you join our team, a lot of all the things we'll be doing is going to be on Kubernetes. So you might be on a project where you have to set the Kubernetes cluster up, or you need to start writing models on a cluster that is already set up. So this is the lay of the land. There's something called namespaces. A lot of you guys are probably familiar with that now if you've been doing a lot of things on Kubernetes. So you have the namespace for each user. So the namespace basically is like a partition of all the things you do, your pods, your resource, your secret, your config map, and everything around what you do. So that allows you to like segment all these things and create a profile where you can allocate resource for developer and things like that. So once you've done that, yeah, you can have your data scientist 1, data scientist 2, working on the namespace. So that way you create a kind of isolation. So that if you're working on something, somebody's not messing up your work and stuff like that. Then you can have a team set up where you have a team profile and you can have all people working on the project in that team in that namespace. And in that case, you can go into production deployment. You can have your production deployment in that environment. You can have your staging and you can have your dev and things like that. So once you have your namespace, you have access to all this resource. Some of you might have seen it if you've been able to successfully set this up. You have all these resources that you can use to like bootstrap on your environment, set everything up. You have your Jupyter notebook. If you're doing things in R, you can have R embeddings as well. You can have PyTorch framework, you have TensorFlow framework and everything all in this space. And you have your Jupyter notebook booked up so you can start writing your model, deploying it, running it. And the beauty of this is like it's a shared infrastructure. So we can start with like a 3-node cluster. And during the day when there's a spike in traffic and utilization, we can deploy more stuff. And once the resource utilization goes down, you can basically wind things down and stuff like that. So the whole process is managed by Kubeflow. It's an open source project, and I know a lot of you guys have been trying your hands on it. That allows you to do all these things and manage all these components and stuff like that. So we're heavily involved in that. So the other thing that you guys in touch, but we'll be working heavily on this, is authentication. So how do you secure your resource so that anybody in the organization doesn't go and maybe mess up with a Jupyter notebook if you have a namespace? So let's say developer Bob or someone is on that team. Oh, sorry. Someone on our team probably did something in this namespace. You want to protect your work at the end of the day so that I don't go in and mess with it or just change something without you knowing. So there's an authorization layer that we do with our Istio. Some of you may probably have seen it in documentation while you're stumbling around, but we do a lot of things around that as well. It's a service mesh that allows you to control how your service talk to each other. And you can have an ingress gateway. You probably saw things around ingress that allows you to control the incoming traffic. So the HTTP traffic needs authorization. So you're required to do like an authorization to get inside the cluster and every resource you have in there. So you have each user needs to be authenticated to their namespace or to the team profile namespace that they need to get to. So, and there are different ways of doing authorization through standard OIDC providers. You can use Google authorization, kind of like what you see on most of these websites now, that whenever you want to log in to the website, they'll redirect you to Google. Google authenticates you, then it gets you in. We've done stuff like that before. You can authenticate with Okta. A lot of enterprise do that right now, where they use something called Okta. It's an enterprise level IDC provider, and allows you to like authenticate and go into the cluster. We do it a lot for our enterprise customers. So once we do that, you get authenticated and you can access the resource, and you can access the resource you've been assigned to, and you can work in your own environment. So one of the advantages of this is like we're creating a culture around MLOps best practices so that a company that normally takes 6 months or 3 years to get a model out, they can have a process in place and knock out these things in like 3 weeks. And this process is repeatable, it's scalable, and it's a lot more collaborative so that you can work across organizations and different teams to get all these things done. So the other cool part of this is like you can now connect to external resource. In this case, we're talking about Google on the Google Cloud. So let's say you have external resource like PubSub queue, data storage, where you need to store your data files, Cloud Function, BigQuery, and all those good stuff on managed services, good stuff on Google Cloud. You can have your service account connect to it, so you have access to like connect and pick up all this resource and consume it. So a good example of that would be like if you have your data sets, your image files on Google Storage Bucket, and you want to access it through your Jupyter Notebook to do model training, you can easily go in there, train the model, get a resource, and move on from there. So on a high level, that's how all these things work, and that's how you set up your environments for people in your organization if you're working across the enterprise and things like that. So we do a lot of this. We try to automate the process through GitOps so that all these things can be deployed, scaled out for our customers easily and things like that. So that's on a high level part of what we do. So let me go a little bit more into details. So for the traffic and everything that goes into the cluster, I mean, we need to like create a profile for a user. So we provision a user profile. So every time a new user, a new data scientist join the team, we provide a profile for them. And once they're done, we delete the user profile. Then, oops, sorry, this thing keeps bouncing around. We create a profile for them. So we can delete the profile and we can create a binding for the user profile. Binding means like if I want to add you to a team, I can bind you to that team and your profile to that team, and you can start seeing everything going on in that team. So a lot of the organizations we work for, each individual data scientists have their own namespace where they do their stuff. And once they're ready to, let's say, deploy something into staging or production or dev environment, they use a team collaborative namespace, and everybody can now see what's going on. You can share your notebook with your teammates. They can peer review with you. They can look through your algorithm and everything you do and stuff like that. Again, everything is secure through any OIDC provider. In this case, this is for like an enterprise customer that we've worked with, so it's Okta. We have things we've done with Google, we've done with GitHub, and we tie it to LDAP as well, so that before you access the resource, we authorize you, we make sure you have the right profile, and once you have the right profile, we can redirect you to the resource. And of course, you have your notebook and all this stuff. So this is just a zoomed out high-level overview of how things lay out and things like that. So how do all these things work? We basically use GitOps, like I said. GitOps is a way, it's a play on DevOps where you can use Git to manage all the resources. Right now, we're heavily involved with Kustomize for managing our content and pushing things out. So every time a new developer comes and joins the team, the data scientists, the whole idea is to abstract the data scientists away from all the underlying engineering mechanics of these things. So that's where the ML engineers and data engineers come into play. So we come in, we create a profile, we push the resource, and everything just builds and creates in the environment. So other than that, the other big thing that I will share with you, and we can get into the question and answer session, is like after training the model, what do you need to do? We need to do the model serving. So model serving is how you serve your model and make it available for someone to consume it. So it becomes an API. It gets containerized in a container. So basically, we'll follow the same approach. So let's say this is a data scientist on the Kubeflow platform. You're training your model. You deploy it. It picks up the data, does some ETL on it. You do a roll-up. You train the model. Once you train the model, you drop it in the storage bucket. As soon as a model lands, it's going to get a version number. It's going to trigger an event. So we'll use that event that gets triggered because every time something lands in a bucket on the Google storage, we pick it up. And we're like, okay, a new model just dropped. So the question is like, is the model better than the old one? If it's better than the old one, we run some validation testing. I think most of the time we're updating the validation to the part of the training pipeline as well. So this slide is a little bit behind. A lot of all the new pipelines and models we're building, we have the validation step where we validate the model. And once we validate the model, we push it to the storage, location with version target. And the new model can now be promoted for serving. So there are different ways of serving model. You guys have not worked on that, but eventually you get to work on that. It's really cool. So you have KF7, uh, which is allows you to like load your models and wrap it up and basically start serving. You have Celadon. It has a lot of cool stuff to it and everything. Then you have TF7 mainly for TensorFlow. Then there's PyTorch 7. And if you think any of these other satisfy your requirements, you can do your own serving as well. Again, the serving mechanism and everything, we try to keep it up on Kubeflow as well. So you can now have a server, and that server connects the user to authenticates the user. So before you start consuming and inferencing on the model, you need to authenticate as well. So you have like an authorization key, and once you have the right authorization, you're able to like start serving your model out and things like that. So on the high level, that's the model serving component. We'll get a lot more deeper into it, and because that's the eventual thing that the eventual output of the whole process. Once you train a model, the model is now intelligent enough to be able to help you do inference, and you wrap it up as a normal API. I'm sure a lot of you have written a lot of API in Python or any other language, so you can wrap up the model and you just send a JSON request to it. It's going to identify. You can have a model that can predict people's age, where you send in the image, it returns a response and tells you like, okay, this person is like 20 years old, 30 years old, or 80 years old, and things like that. You can have a model that can count the number of cars on the road, the number of cars running through a stoplight and stuff like that. So this is how you inference, and this is how you do a lot of things. We've done a lot of things around this in model serving, prediction, document extraction, and document processing. Invoice processing, where we have models that can understand what's on an invoice and basically return a JSON payload of all the entities on that invoice, so that you can have it in a structured format that you can use in your database, use as part of your put in your database and use as part of all your other enterprise process and things like that. So on a high level, that's how everything ties together. I've done a lot of talking. I just want to throw it out and hear back from you guys as to what you're doing, what your challenge is, and how we can keep the ball moving and get things going. Thank you.
Thank you so much, Charles. I've seen that your presentation actually addressed some of the questions I have here with me. Well,
Okay.
first off, I think we should allow the interns to actually talk, and by raising their hands, so we can unmute them and hear what they're actually facing, because some of the questions that they have are actually technical, involving some code errors like KFCTL. So
Okay.
if you have any question,
Oh, yeah.
just raise your hand so I can unmute you, and then you have the chance to speak.
Oh, yeah, sure. Let's do that.
All right. So is there anyone? Yeah, okay. I've seen one, Mohammed. So you can talk now, Mohammed.
Okay, good afternoon.
Hey, good afternoon, Mohammed. Yeah, we can hear you.
Okay, my major problem was getting the free GCP credits, the $300.
Oh, okay. So, yeah, I understand. Yeah, well, yeah, go ahead.
They asked me to do the verification to use my bank statement or my card. I tried both and none. They've still not verified my account up till now. I don't know.
Okay. Okay. Yeah. Sorry about that.
My other question is that the resources that were given, they were majorly on Kubeflow and not Kubernetes. And this stage was supposed to be setting up Kubernetes, but like the major resources they gave us.
I think she's glitching out. Can everybody hear me?
Yes, I can, Charles. So I'm trying to unmute her again so she can talk. Mohammed, can you hear me? I think we've lost her.
Okay. I will address the question, and she can always private message me as well, or just reach out to us after that, just to help out. So I understand a lot of you guys are having challenges with JKE, the managed environment. We're still thinking about how we can do this, but one of the things we're looking at doing is if you're having challenge with it, maybe we can set up a cluster and just give out access to people so they can use it. it's going to be a shared resource, so you're not going to be able to have like 100% control on top of it. So basically, we can allocate time slots and you can run your stuff on it. So if you're having any problems, let's create another group on the Slack channel and just key in all the problems you're having, especially people having problems with like connecting to the JKE. Just because of the verification and the cost and not getting the $300 credit. If you can just create, let's create a group chat and just get a count of people on it, and we can get you access to run all those things. And it's going to be a shared resource, like I said. So you just have a time window, maybe 3 days per person or 2 days, and once you're done and you have everything, you can document or record all the things you've done and you can present it to us. So I think that will allow us to solve it. So that was the first question. And to address the second question, the question was around like, okay, this is around, the test was around Kubeflow and not Kubernetes. And I get it. And the thing we're trying to do is like make you guys problem solvers. I mean, it's like me saying you should go to London. You got to figure out how to go to London, so from Lagos, and you don't have to like. I don't want to tell you all the steps. Like, okay, go board the plane. When you should board the plane, fly to this place, take a connecting flight, then go to this site and things like that. So that's part of the things we're looking for. It's I love all these things. I have a lot of embeddings in them and layers in them. So if you start to one thing, it's going to trigger more questions, and over time, we want you to figure out the path. So the whole idea is to like, okay, I want you to do this, but this has a lot of dependencies embedded in it. Then solve the dependencies and document how you solved it, then solve the problem I wanted you to solve. So I think that's very important, especially if you want to be very successful with all these things that we're doing. A lot of all these things are loaded. We basically understood that you're going to need Kubernetes before you get on Kubeflow. So that was a necessity. So the whole idea is to just understand these things, go through the layers and peel. It's like you're peeling onions. So you got to go through all the layers and solve the problems. And if you run into any rabbit hole, just reach out. And this is a very collaborative effort. So if you're having any problems, just bring it up and someone will help you. And I can jump in as well. And we want to learn from you in this process because people do things in a lot of different ways. So if your way is better than the way we do it right now, obviously I'm all ears. I want to listen to you and learn from you as well. Does that answer that question?
Yes, I think it does, Charles. So I've also been seeing some questions also
I think she's back online. Can you unmute her real quick and let's just see if you picked it all, or if not, then we can basically.
Okay, sorry, my network was bad.
Oh, that's fine. Yeah.
My network was bad, so I got the shared cluster.
Okay.
So I think it'd be nice to actually have you spin up cluster so we can just connect.
Oh yeah, that's what we're saying. So let's create a group and see people who can have access as a result. Then we'll create a shared environment, and within that shared environment, everybody will have a time slot. And once you're done with your stuff, you vacate it for someone else to use it. So I think that will solve the problem. So we'll circle back on that and touch base with you, and we can see how we move this forward. Thanks a lot for your effort.
Okay, thank you.
You're welcome.
Thank you, Charles. So we have another question from Wally. Wally is raising his hands. So Wally, I'm unmuting you now.
Okay. Good afternoon, everyone. Good afternoon, Mr. Charles. Can you guys hear me?
Oh yeah, I can hear you. We can hear you.
All right. So thank you so much for this session. So I have a couple of questions. Pardon my ignorance. I'm really very new to this to the whole Kubernetes.
It's all good. Yeah.
So okay, when I created my GCP account, I saw different videos on how to get started and everything. So I was able to go online, go on YouTube, and understand how to set up. Understanding that I need to set up a cluster of virtual machines before I can be able to actually run anything. So later on, when I was setting up the clusters, first, when I was setting up my cluster of virtual machines, I had a problem with the zones. I kept saying something on quotas, like I needed to understand the restrictions that I had on my quotas. Then I saw another video, where I had to use a mini KF as many kubeflow
Yeah.
to like I didn't really understand. So like go from the process, the stage of moving my model. We worked on the Titanic data sets, moving my model from the model created in Titanic data sets from the Jupyter lab and then uploading it to the server or something. So I don't know if you could really I don't know if you could take time to break down the steps from creating my model from Jupyter lab after I've worked with my model and everything. After my model is ready, after that, how would I then upload it to a server? And then from the presentation you just gave now, I think I understood the fact that okay, the data engineer, the MLOps and the DevOps engineer does works from the back to actually give the data scientists like access to work on these models and everything. So I would like if you could really explain that aspect.
Okay. Yeah. Well, a quick question for you though. Are you doing the data science track or the data engineering track, or what you on?
Data engineering.
Oh, okay, cool. Yeah. So basically, there's several ways to skin the cat. How do they say it? So basically, the whole idea is like you want to be able to set up your Kubeflow infrastructure. So one of the things that you can do is to run it on your laptop. So there's something called the Minikube, and you can basically set up Minikube and install Kubeflow on it. There's something called the Minikube as well from a company called Aricto. I know a lot of people out there, very good companies. So they've done like a Minikube flow implementation that allows you to just download the Minikube and run it. I know it runs well on Mac and Linux. I'm not sure of Windows. So you can do that. So then the other option, these are options that for you running all these things locally. The other option is to run MicroK8s. So MicroK8 is from Canonical, the company behind Ubuntu. So if you're running Ubuntu, or if you're running a Mac, or if you have a VM running, I mean, especially Ubuntu, I think that would be the best bet. You can do a snap install and install MicroK8. So it's a tiny version of this that allows you to run everything on your Kubeflow. Actually, we did a talk around that. I'm going to share the slides and everybody can just follow it. So I'll share with
Okay, I would appreciate the slides.
I think it's a video actually. I'll share it and we can follow. You can learn a little bit more from there. So those are the ways for getting started on your local computer. But for you to do that, you probably need to have a strong laptop or MacBook with decent memory, and because you're spinning off a lot of files and running all these things. So I'll say at least 8 GB just to like get things going of memory. I
Okay.
think that will allow you to do it local. So the setup takes a while, but I think you can nail it. Then once you're done with that, you need to graduate because all the things you're doing on your laptop is just to get familiarized with the ecosystem and the commands and how things work. So once you're done, you now need to move things to the cloud. So that's where setting up this in the cloud or on-prem. Some companies don't want to go to the cloud for security reasons. Some are okay with running things in the cloud. So if you're on the cloud on Google, Azure, or Amazon, they have managed Kubernetes cluster. Managed meaning you don't have to install the servers and set up all the things around it. You
Okay.
can just bootstrap a JK instance, specify the number of nodes you want in the cluster, the version of Kubernetes you want, and everything gets automatically deployed for you. So once you've done that, there's something called KFCTL with a Kubernetes Manifest. The manifest is based on customize with K. It allows you to basically deploy all this resource and infrastructure. Because like a lot of you will have seen, there's a lot of YAML files that you need to deal with, and managing
Yes.
all these things is a pain. Especially you're still dealing with one computer. Just imagine you're dealing with multiple environments and you have several customers, which is the case for us. We have customers running on-prem, in the cloud, different cloud providers, Google, Azure, Amazon, and stuff like that. And we want to manage their deployment. So for that, we rely heavily on the Kubeflow manifest. So the manifest contains different installation paths for Amazon Cloud, for Google Cloud, for on-prem, for DEX, for Air, for all the different instances, AWS, and even on IBM as well. So we just take this manifest, we prepare it, and we deploy it. So we automate the process as well with our GitOps. That's part of the things we're doing, but you don't have to worry about that right now. Just get Minikube working, get everything up and running, and let's try to do a demo around that. And if once you do all of that, I think you're gonna be okay running things on the cloud eventually.
No, all right. Thank you very much. Thank you very
You're
much.
welcome. Yeah, I'll send you the slide link, by the way.
Okay. Thank you.
Yeah.
Yes, thank you, Charles. We have another question from Mayowa. So I'm unmuting Mayowa.
Okay.
Good afternoon.
Yeah, good afternoon.
Yeah, so thank you for the presentation.
Oh, you're welcome.
So my question is the documentation provided by Kubeflow, right? Is obsolete, and they actually say that themselves. For example, when you want to install, customize, YQ, all those stuff, many of the steps are not longer, they're no longer what you use now. So I want to ask, are there alternatives? Because that personally, that's what has been stopping me.
Yeah.
YQ, it has been from one issue to another, customized. I went to the GitHub repo, I cloned, I downloaded Go, I did a lot of that, and it's still giving me issue. I don't know whether there's alternative. And then I think it will make more sense, even if I'm going to, spin up a Kubeflow now. I don't have to install YQ all the time or customize all the time. So I don't know if there's any alternative to this.
Okay, cool. That was a very good question, and welcome to my world. That's the kind of problem I have, and that's what we're trying to solve. So, and I was smiling during when you were saying that, because I run into that problem daily. A lot of all these things are very fluid. Someone like you and I is actually working on the other end. That's why it's open source. So the whole idea is to, like, we want to push ourselves to become subject matter experts in this area, so that as things change, because all these things are changing very rapidly. Like there's Kubeflow 1.1 right now. A few weeks ago, I was installing 1.0, and I was running into problem with it. And if you go to 1.0 documentation, the market is obsolete. They're now going to 1.1. So these things are rapidly evolving. As people discover smarter way of doing things, they try to incorporate it. Once the community agrees with them, they get it in and stuff like that. So it involves constantly evolving process, and that's what we want to derive from this program that we're getting you guys into, for you to be able to evolve and not just be a consumer, but be able to give back. So eventually you're going to be smart enough to, like, understand, like, okay, these things have changed, this is a change. And or if you have an idea of doing things in a better way, you can submit a pull request. They will accept it. Or you can see all the documentations that are obsolete, and based on what you're doing right now, we can contribute back and give them, like, hey, this documentation is obsolete. Can you do this, or can you take it off, and things like that. So those things are constantly changing. And I think once you get more deeper into this, we can, especially with all these things, we can ask questions. I think all this is a very valid questions. You should bring it up on the group chat. For me, presently, we manage a lot of installation around 1.0. So I think I'm very comfortable with, like, running the Kubeflow, setting up things around the 1.0. And I'm going to start learning around 1.1, what's the change, what's the delta. And at the same time, I still have a lot of customers running on 1.0 that I need to support and make sure they're doing okay and nothing is breaking. So understanding all those things and keeping track of what changed between versions, and when is the right time to move to the next version. So that those are the smart decisions that you'll be able to take over time. Because one of the things you try to do as well is, like, if something is new, you don't want to jump on it or put it into production, because if something screws up, you may be bringing down a big system. So you try to observe it and make sure things are stable before you migrate to that new version. So, and the rule for me personally is just stay a little bit one step behind and test things out, new things out in a sandbox or dev environment. And once you're comfortable with it, then you can pull the trigger and migrate your customers to the new environment. So, but the challenge is basically managing all these changes, and there's nothing we can do about it. As people think of smarter and better way to do things, they push it out there. Once people think it's nice, they adopt it and it becomes part of the ecosystem. So it just shows you how fast you need to work and evolve, because something you think is okay right now and it's good to go, it's going to be obsolete by next week. So the way around that is to just be on top of the game, be a subject matter expert, understand why things change, and eventually be the one pushing things in that direction, or be a voice in the community. It's all open source. If something is changing, and you don't like it, you can raise your voice, and people can back you if they think what you're saying is valid, and they can alter change or things like that. So the project is very active. If you go check it out, there's a lot of pull requests, different components coming in. A lot of companies submitting different patterns of doing things and stuff like that. So it's interesting. That's why a lot of people will always have a job, because all these things are evolving, and it's a common knowledge of what someone else, what just one person can say they know and not keep learning or improving themselves on.
Okay, thank you.
You're welcome.
Yeah, thank you, Charles. I will be unmuting Ifoma.
Yeah.
Good afternoon, and thank you for this opportunity.
Oh, sure. You're welcome. How's it going?
Very well, thank you.
Oh.
I just want to ask if it's possible for us to have a kind of presentation where we are put through the various steps of deploying Kubeflow on the various platforms, and a good number of us are trying to do that on GCP, and we've been having a lot of issues, technical issues, because obviously we can copy and paste what we see, the codes we see, but then we run into one or two errors and we are not able to navigate through it. So if you ask everybody to start asking questions, they will have will have various questions to ask based on the problems we're having, ranging from quota issues on clusters and installation of some, some dependencies, I guess. So I think I'm just asking if it's possible for us to have a breakdown of the step, or maybe we can have something like this again, where everybody would follow through like a lecture, or a kind of a lecture where everybody the process is being displayed and we all follow through together and then get it done.
Yeah, that's a very quick question, and that's a very good question actually. So, well, you said something that I want to call out. You just don't copy and paste. You want to understand what people do, and that's very important. Just don't copy and paste. It's better for you to understand how things work than just making a clone of it, which is.
I understand. I just said that's like the basic thing everybody can do, and we have.
I know, and I don't want you to be everybody. You need to be it's very, very different from everybody. So, the whole idea is to understand this thing. So, a lot of times, like anything in life, the first time you do, you won't get it right, and some people will get it off the bat because they've probably done something similar to this before. They're lucky and they're just going through. I run into a lot of rabbit holes like that too, where it takes me like weeks to figure out something, and sometimes you get it right away. So sometimes you're like an hero, and sometimes you're just zero, and nothing comes to you and stuff like that at that time. So one of the things you want to do is to make sure you understand all these things, and you may not be able to run at the right pace right now, probably because it's the first time you're seeing this. But if you keep at it and you're persistent, eventually you figure it out, and you need to ask a lot of questions. And this is the first quad that we're running. We're going to have multiple of these as things grow. But one of the things you can do is just keep learning all these things, understand the paths, understand how things fit together. And I agree with you, we can have more sessions like this, but at the same time, you don't want to spoon feed people like, okay, just click on this, go through this step, get this done and stuff like that. I want you to have problems. I want you to have challenges, because that's how you learn. So if you're not running through all those things and making mistakes, then you're not learning anything. I'm just being practical and honest with you, because the fact that you're running into all those things means you're like making progress, but it's not noticeable right now. But 2 years from now, if you're doing some other things, you'll learn from that mistakes that you've made. So, but if I go in and just do a presentation of how I set up Kubeflow for you, which I've done a lot of times, and I made a lot of mistakes, and I got out to do it finally. If I give you the blueprints and you just run it and everything works, you're not going to appreciate what it takes to become a data engineer or MLOps engineer. Or it's not going to help you too, because you might just get into a situation where, because you didn't run into all the problems you're running into right now, you won't be able to solve it, because it's just copy and paste, just quoting you. So you want to be able to, it's good to run into all these problems. And once you run into it, you ask people, you learn from that, and you just keep moving on. So it's not going to be like a straight road. It's going to be like lots of good times and bad times, and bad times and good times. And at the end of the day, you learn. So that's what knowledge is all about. So you're basically not just getting a dump and just go straight, and you go straight. I'm just telling you to go there, and in the process of going there, you're going to meet a lot of things on the road. Just solve it, and if you can't solve it, call out to someone that can solve it. Just figure it out. So, but I agree with you. We have more session like this going on. It's good, but I don't want to. We don't want to have people on the team that we're going to be spoon feeding and telling you, okay, this is how you do it, and just follow instructions and just execute things. The whole idea of this is to force you to think and be able to independently solve a problem. And once you solve it as well, you become like the road master for someone else coming on that road. So if you figure out how to deploy this, just document it so that you understand what you did. So if someone else is running into that problem, you tell them this is what you did and everything, and you unblock them. So it's a lot more collaborative rather than top down. Someone just give you the templates and you run it and everything is okay. It's just you figuring out all the possible mistakes that you can make, and we all get our mistakes together. We learn from each other, and we can evolve and have a practice where we know how to do these things in a very good way, and everybody can be a contributor rather than just following instructions and executing a program. Does that make sense?
Yes, I understand, and that's perfect. I mean, that's the way we've been working, and in
Yeah.
all sincerity, I've learned a whole lot, and I'm sure a lot of persons have.
That's the whole point. I mean, so eventually you're gonna get it. I'll say it takes a lot of persistence. So I mean, that's why I'm trying to get to that. You may not be able to get this done in a weekend. Maybe someone just get it done in like an hour. But at the end of the day, you may know a lot more than the person that did it in an hour, because you've known a lot of ways not to do it, and you know a lot of mistakes that people can make. So you're basically building a lot of knowledge along the way. So I mean, people learn at different paces, and you understand things in different ways. So just stay with it, stay persistent, and keep asking people. Actually, I've been on that Slack channel as well. So just ping me if you have any questions, or just I can unblock you, someone else can unblock you. But at the end of the day, you learn a lot more that way. So it doesn't really matter that, okay, you got to pass this and move on to the next. So just take your time, let it sink in, understand the process, and you'll be a lot more better than someone that just got it right away. At the end
Okay,
of
so
it, well,
we've been on this for about 2 weeks now, and
right.
we have a deadline.
Yeah.
So that's why I was making this suggestion. Yeah, we can definitely go back and go through it. Everybody must have had their own fair share of trial and error, and would have picked up one or two things along the line. But I just feel we need this so that we can proceed to the next stage. That's why I'm really making
yeah. I mean, we'll do this more often. Just come up with some specific questions of the problems you've had, and but one thing we don't want to do is to just create a roadmap. There's a solution to this. Obviously, people solve it. A lot of people have done it. So, and what I'm trying to say, even though we have a deadline, that deadline should not be your like, okay, you have to get it done at this stage. At the end of the day, what we want to do is like, how did you solve the problem? Where did you go? How did you approach it? What was your problem? And some of your problems will be valid. Maybe it's a bug in the application that they need to solve, and you just find it, you're running into that rabbit hole because you're finding the bug. So the fact that you're not getting it done doesn't mean you're wrong. So at the end of the day, at the end of the sprint, what we want to do is like, we'll review your work, we'll see what you've done. The fact that you set it up and it's up and running for you doesn't mean you know what's going on. So you may even qualify for the next stage if that's what you're thinking as the yardstick for moving on to the next stage. You can qualify over someone that has everything already set up, because what makes me feel that person didn't just follow an instruction and get it done. So it's all about this problem solving skills and how you approach all these things and how you get from stage 1 to stage 2 and things like that. So what I would suggest is if you have any problem, bring it up, and just if you can, just private message me some of the some of the problems you're having, and we can just have a group and just debug things. And like I said, some of your problems may be a valid bug in the system, and some of them may not. So, but the whole idea is to just make sure you're putting the right efforts, and you understand all these things, and you're basically trying to solve things in the right way. But I would say, like, let's follow up after this call. Maybe we can have a Slack channel dedicated to some people having the same kind of issue, and we can try, solve it together. I think that'll be helpful. But I want you to understand it. I want to see you approaching your solution, and I can see how I can help you from there.
Okay, thank you very much.
You're welcome.
Thank you, Charles.
Okay.
That was really helpful. So even at that, on Slack, based on the result of the poll, we have 49% of the total number of people that have filled in have actually succeeded in actually deploying and setting up Kubernetes. So I think if I can also make use of the platform to and ask some interns there to also assist. So let's quickly move on to Emmanuel. He's raising up his hand. So Emmanuel, you can talk now. You're unmuted.
Good afternoon. Can you hear me?
Yeah.
Hello. Good afternoon.
Yeah, good afternoon.
Yeah. So I just have a little question concerning deployment. Everyone seems to be deploying using GCP, Google Cloud Platform, and I've also tried using it. I ran into errors. So I've been thinking, and I just wanted to ask, what do you think about deploying using Kubeflow with Amazon SageMaker, the combination of the infrastructure that Kubeflow provides, and then the amazing SageMaker kind of has some good features to it. So what do you think about the combination of those two? Is it something that you can actually look into, like personally look into, or do we have to follow the set part of GCP and everyone has to use the Google Cloud Platform?
Yeah, there's a little bit of feedback if we can mute him. Yeah, cool. Thanks, Emmanuel. So I think you're getting things mixed up. SageMaker is very different from Kubeflow. SageMaker is the Amazon proprietary product that allows you to train and build models, and it's all tied into the Amazon ecosystem. And I know some people try to run SageMaker operators to bootstrap SageMaker from Kubeflow as well, but they're two different things. So I'll say just try to understand the concept and not mix it up. I think that's very, very important to get this going. Kubeflow basically runs on Kubernetes. What that means is the underlying infrastructure is Kubernetes. So if you're running on Google, it's JKE, I think, because Google is driving this project and they've open sourced this. So a lot of the documentation is a little bit biased towards setting up on Google. So that's why a lot more people set it up on Google. But you can do the same thing on Amazon. I've worked with a few Amazon guys, and a lot of Amazon contributors, AWS contributors contribute to Kubeflow now. So you can run it on Amazon as well. So they have the installation process for Amazon. So a lot of all this is mainly, I think, can you install things with KFCTL and the manifest? Do you understand how those things work? Do you understand customize and all the stuff around it? So I'll say try to understand it depending on what environment you're using. And if it's on-prem, if it's on your local, you can try to understand it as well. So once you understand all those, you can now, it's all platform agnostic. The underlying operating system in quotes, if I can say that, is Kubernetes. If you have Kubernetes running on anywhere, even on Mac, you can install Kubeflow on top of it. So that's the baseline requirement. So you can do it anywhere. You can do it on your local computer as well. So try to understand the difference between SageMaker and Kubeflow. They're two different things, so don't mix things up. Maybe you have any questions around that, we may be able to help you with that as well, but don't mix things up. They're very different.
Yes, thank you, Charles. Looks like we've covered all the questions on. No one is raising hands again on Zoom, so let's move on to Slido. So we have a few questions on Slido. The first on my list is from Mba. So please, I would like to know how Kubernetes does orchestration. How does it really work? What are pods and deployments?
Yeah, that's a very good question. Maybe we should have another session that talks around Kubernetes and things around that at some point. But that's a very valid and good question. So I think that's this. The cool thing about it, I'm saying, is like it's pushing you guys to learn a lot of things that you probably didn't anticipate before this, and that's very cool. So for you to be able to succeed on this, because the whole idea is to have this as a trigger point for you to learn some other things like Kubernetes, Docker, containerization, and within Kubernetes, you need to know about pods, service, deployments, stateful sets, daemon sets, and what else? Ingress and operators and things like that. So that's the whole idea. So I mean, we can have a session where we talk about Kubernetes in details, but I think once a lot of people understand these things, it's something you can read yourself, maybe to get started. We can share some materials with you to like go deep into that, understand it, then you can now appreciate a lot of what you're doing right now. So, but what we've done is to take your eye up there, then in the process of staying there, you need to be able to go through some things, and all those things are like trigger points to do all those things. So I'll send some resource to you that you can check online to read up on this, and if you have questions around it, you can have a follow up and things like that. And eventually, one of the things we should be doing as well is to have subject matter expert amongst you, someone that have really understood all these things that will do a presentation. We don't want this to be a top down thing where we're the one driving things all the time. We want to build great engineers and great ML ops and data scientists that can just come up and talk about the things they're doing. I'll share some materials with you to get you in the right direction, and we can continue from there.
Yeah, thank you, Charles. Even the second and the third questions are somewhat similar to what you just said. What is the use of Kubernetes? Is it because of it is computationally intensive? And I think from the materials you said you'll be sharing with them, that might address all these questions.
Yeah, exactly. But let me just quickly talk about the advantage of Kubernetes. So the whole idea of Kubernetes comes from Google. They've been using it for years, and they basically started it and open sourced it, and it's a big thing. So the way Google works is like they have a lot of distributed computers. Everybody's using Google Search all over every time of the day, and the resources needs to be allocated properly, because you've never gone to Google and it's down before. It's almost on all the time. So all these resources are all deployed across in a distributed environment, and the whole management structure is around the whole idea and architecture of Kubernetes, where you can allocate a resource and scale things up on demand. So the way of doing things before Kubernetes is like, okay, I want to set up a web server. You buy an Apache web server, you put it there. But the Apache server may not just be using maybe 1%, 15% of the CPU, maybe 10% of the memory, and you have a dedicated web server. You can't really scale things out elastically. So what if your web server or your business just grew and you have 1 million users? That means your application is going to keep crashing because a lot of concurrent users are trying to use it. So the whole idea of Kubernetes is to have an elastic infrastructure where you can scale things out on demand. So if I have maybe 100,000 customers, I can handle it. But if all of a sudden I'm in the news, I'm trending on Twitter, and my company becomes a company where I need to serve 100 million customers concurrently, how do I deal with that without crashing or a good problem becoming a bad thing for me to manage? So that's where Kubernetes comes into play. You can basically scale things out elastically. You can scale out the underlying infrastructure. You can scale out the pods and things like that, so that during a spike in traffic, you can accommodate all the incoming requests. And once the traffic spike goes down, then you can scale down the resources again so that you're not paying too much for it. So it's like a scalable resource on demand, and Kubernetes allows you to do that. And that's the beauty of it. That's why a lot of companies are gravitating towards it right now. So so that's the situation with Kubernetes right now, and that's why it's kind of the next big thing, and a lot of people are moving towards it from the traditional way of doing things like application servers, web servers, and things like that. Any more questions?
I think we've covered all questions. So the questions that we have here are majorly technical questions, and which I think you've addressed by stating that each person will have a particular time whereby the person goes and visits his cluster. So and also please, I created a poll in the data engineering channel, and if you know you're having problems installing Kubeflow or setting up Kubernetes, okay.
Yeah.
Okay, if you know you're having problems setting up Kubernetes, you can go back to visit the poll again and select your answers. So when we are done with this call, I can add you all to the private channel and you can get unblocked there properly. Also, so let's take this question. My problem is by Bede on Zoom. My problem is insufficient project quota. The Kubeflow needs 16, mine is 12.
I think you have some other things running. If you don't have any other things running, I think you should be good on that. So I think if you're trying to do stuff in that project namespace, make sure you don't have any other thing running that's taking up the quarter, especially if you're using the free quarter. So I would say make sure you have your stuff from scratch. Just make sure you don't select the beefed up instances. The micro or the standard instance should be okay. Then make sure you just start up with 3 node pool. You don't need anything fancy. Just don't try to overkill, because they're giving it to you for free, so you don't want to take too much and be greedy around it. So just take just what you need and you should be good.
All right, thank you, Charles. And we have another one here from Chris. My issues are basically with the customized.yml file not being found in my PWD to help me build my clusters and subsequently deploy the Kubeflow on GKE. I checked the PW and the customized.yml file and it is there. Please, can you explain more on what could be the problem?
Okay. So can you repeat that question again? I didn't get the last part.
Okay, my issues are basically with the customized.yml file not being found in my PWD to help me build my clusters and subsequently deploy the Kubeflow on GKE. I checked the PW and the customized.yml file and it is there. Please, can you explain more on what could be the problem?
Yeah, so I think in that kind of case, I think one thing we can do too is probably have like an office hour where people just share their screen and we can go through things and knock it out real quick. But I think that problem has to do with like your customized file not in the same root path or the same directory where you're trying to find it. So make sure you have the customized file. Sometimes you have the .cache that's previously downloaded. So you do ls-a and remove the .cache. And if you have any existing customized folder there, you want to delete it. But if you have everything in place, you can just kfctl-v-f apply, then the customized file, you should be able to install it. And the other thing you want to make sure you have before that is to have your kubectl set up so that you can basically, you have your Kubernetes set up. That's with kubectl, you have your config in place, because customize depends on that and kfctl depends on that. So if you don't have all those underlying things, then you're not going to be able to invoke the kfctl command and have it work. So just make sure you have all those correctly laid out. So, but I think we should have a working session and we can have guys on this team as well that have solved it on that working session where people just share their screen, quick 5-10 minutes, walk through what they're facing, or just do a video recording and post it out and someone can call it out. I think the video recording might work as well. So just screenshot your screen and show what you're doing and where you're running into problem. And someone can help you and just tell you what you're doing wrong or what you need to fix.
Yeah, sounds like a plan. I think that will work. And the last question on my list here is from Mba on Slido. What does this error mean and how can it be navigated through? Cannot execute binary files, exec format error.
Cannot execute binary files.
Yeah. and it's pointing to the kfctl directory.
Maybe it has to do with your permission around the Linux kfctl file installation. Make sure you have the right permission and the right access. So that's what I can think of right now. But I think this is going to force you again to go know your Linux command and know how things are working on Linux, how you grant permissions to applications and stuff like that. So that could be the problem. So, but I think that kind of question can be solved if I see it visually. I can call things out, or I may not know the answer and someone else out there can know it. So, yeah, I think that's a good thing for a working session. But off the top of my head, I think it has to do with permission.
All right, thank you, Charles. So it looks like we've covered all the questions on Slido. Is there anyone on Zoom that would like to ask the last question? You can just raise your hands. Going. I think that's all. Charles, is there any final word you'd like to say before you final wrap up?
I think I'm impressed. A lot of you guys have not seen this, and you're under the pressure to get it done as fast as possible. You're running into a lot of problems. That's expected. It's not easy. If it's easy, then everybody on the street will be doing it. So I think this takes a lot of persistence. A lot of I want to do it. I want to get it spirit. So over time, a lot of things are difficult for you right now. You'll look back in the next 3 months or 6 months, and it will be a cakewalk. And we'll even have you out there mentoring other people coming after you. So I'll say keep at it. Stay persistent. Let's remain collaborative and share and ask questions in the group. And if you have any questions, just reach out. We'll answer you. We'll try to give you feedback and things like that. So I'm very impressed given the fact that you're learning this and you're learning so fast with all the constraints around. So I think let's keep doing this, and maybe we should do this a lot more often. I really enjoyed it, and thanks a lot for your time, everyone.
Great. Thank you, Charles. Thank you, everyone. And don't forget to visit the poll on Slack. We appreciate you for being here today. Thanks again for joining us, and we'll see you another time. Bye.